This really quick video should be able to help you with anything that has a restricted domain. So I just took 4 of the problems from the worksheet above. I copied the answers and we're going to change them to meet the domains that are required for this problem. So if in problem 13 we're looking at integers only, I can't have arrows going everywhere. So I have to be careful. So I'm going to change that so that instead of it being -8 with an arrow to the left and 6 with an arrow to the right, I'm going to maybe extend this number line just a little bit so then it's easier to see. But I will represent this with every integer, and then I'll kind of indicate that more of them happen. So kind of like a ... in English class. So I'm just having only integer values. That also means that I would have to change this. So I can't write that all by itself. I would have to say only integers in that interval notation. Or I could write it in set notation where I'm showing that I don't want to put ... dots here. So -10, -9, -8, and then it stops. Then I have 6, 7, 8, and it keeps going from there. So that could be another way to write that. Problem 14. I have to be careful because it's only the natural numbers. So natural numbers start at 1. So it's the counting numbers that start at 1. So that means I have to completely change what my graph looks like. It would be everything from -3 to 7, but I have to be careful. I have to start at 1. So 1 is the first value that I have. 2 counts, 3 counts, 4 counts. I have to extend this just a little bit. 5 counts, 6 counts. 7 does not count in this problem. So I cannot have 7 because it is less than 7. So that means my only answers are 1, 2, 3, 4, 5, and 6. Or if you wanted to write it in interval notation, you could say bracket 1 to 6, only integers, something like that. Problem 15. If I'm looking here, it originally looked something like this. I would have to do something very similar to what I did in problem 13. So I would rewrite this where I have just just integer values that are negative, and they're going forever in the left, but nothing is going on the right side because I can't have any of this. So I would definitely not include this. I could say -infinity to -10 integers, or I could say ... -12, -11, -10, and then just stop it right there. Finally, let's kind of break this off so that we can see the differences in the problems. One thing, I slightly changed this problem to make it absolute value of 8x minus 24 instead of having the 8 on the outside, but it still ends up being the same answer. I just wanted to point out one more time that if I have something that looks like this on the inside, that does a couple things. First of all, if I factor out the 8, that makes it more obvious that my center is at 3. And notice that this 8 has to get divided or into that 16. So I have 16 divided by 8, and that gives me the distance. So my distance is 2. Now in this problem, I'm dealing with integers only, so I'm not going to have arrows. So I will have, and I won't have 5 or 1 included either. So I'm going to start at 6 and go on forever. And I'm going to start at 0 and go on forever in the negative direction. So I would, um, I could probably do this and say integers, but that's not very clear. So I'd either want to do it as a set, or I could also use interval notation, although I wouldn't recommend it because you'd have to also write only the integers in this, but it would be negative infinity to 0 union 6 to infinity, only integers.